So, I am not Raphael Doms. If you want his presentation, go to the other room. My name is Ian Littman, and we're going to talk about generators and using them to make asynchronous applications that don't make you go insane while building them. So, a little bit of housekeeping here. The weird accent is I'm from Texas, so we have different definitions for words, such as y'all is actually just a small group, and then all y'all is, well, everyone. So to differentiate here, y'all may have seen async and await in Node.js. All y'all should be using PHP 7.1 or above because 7.0 and 5.6 are end of life at the end of this year, so get off of them. Now, what we're going to cover today is what exactly a generator is, what exactly a coroutine is, and then how to use those to make your application faster, more performant, better memory usage, that sort of thing. Keeping in mind that there are certain use cases for which generators and coroutines may not actually be a better solution than your standard Nginx PHP FPM or Apache PHP FPM or Mud PHP worker-based system. So we're going to do that, and we're going to have examples with a real-world application because code samples make you a little bit less afraid of doing some of this stuff on your own. Now, let's start with a simple generator here. We're reproducing the range function here that's built into PHP. Generators end up being a lightweight version of the iterator pattern in PHP, except instead of having to declare a class with about a half dozen methods, you declare what appears to be a function, and you use the yield keyword to spit out values as that function is running. In this case, again, we're just regenerating the range function and encapsulating a for loop, but as you go through here, it'll spit those values out. So let's go ahead and see this in practice. All right, so we go over here. Is that big enough? Okay. View. Zoom in. And more. All right, we'll go with that. So this is going a little bit slowly here. Let's see why. Okay, so I've got a usleep in there that would explain that. But instead of commenting out the usleep, let's see what it was trying to echo there. Oh, there we go. That's why. Okay, so we have that generator. And the key to all this is the yield keyword. We'll get to a country-appropriate version of this sign later. But the idea here is you use... Oh, let me switch back to my presentation. You all are wondering why I'm saying country-appropriate version. There we go. So the idea here is that generators are resumable functions. When you want to spit out a value to be iterated across or just used by the caller, you use the yield keyword. And you can do that again and again and again. Now, what... excuse me. Now, as I mentioned, the idea here is to take an iterator, or at least in the example that I gave it, is to take an iterator and condense it down from a whole lot of boilerplate to a single function. Now, there are also some more fun things that we'll use in order to turn this into something that we can use for async operations. We'll see that in just a moment here. But first, in honor of playing around with the tour that some of us had last night with ghost stories in the Edinburgh vaults, let's go back to another example. So, as mentioned on the slides, we're just doing another while true. We're looping, and one key thing here is that the calling loop, that for each, actually controls the execution of just how much the generator gets called. So we could actually have a for each in there that after a number of iterations cuts off, and the logic, however much logic was beyond that yield, would not execute. That's going to become very important momentarily. Now, I mentioned that you really want to be on PHP 7.1, 7.2, so the fact that a lot of the fun stuff that you can get in generators only becomes available in PHP 7.0 when there was a significant rework to how generators worked under the hood. Now, you haven't seen generators return or yield from or throw exceptions quite yet, but we'll get to that shortly. Also, generators are not a new concept. They've been in Facebook's HHVM runtime and even hip-hop before that for quite a while, even prior to PHP 5.5, and they're available across a variety of languages elsewhere. Now, speaking of returns, the way that generators use the return value is a bit different than how a normal function operates. In addition, merely calling a generator does not start execution. You have to start iterating over it using a for each, or, as we're going to see a little bit later, use methods that are built in to the generator primitive, similar to how Clojure has a whole bunch of methods associated with it, in order to control the execution of that glorified function. So let's have an overly complicated visual example here. On the right, you have our generator. On the left, you have the code calling it. Now, the arrows in this diagram show, in the case of the arrows going back to the parent, what values are being returned when the parent calls a given function, or a given call on the generator object. Now, to start off, we instantiate the generator. Now, I say instantiate rather than call because, in effect, this gen up here is a syntactic sugar on top of basically constructing the generator. It does not execute, it merely provides an initial argument into the function. Now, you go down here and you actually call the generator and say, I want the current value of the generator, similar to what you would do if you were unrolling an iterator. In that case, the generator executes up to the point that a yield happens and yields a value and stops. That value returns over to the caller. The caller can do whatever it wants until the caller calls send on that same generator. Send can either be provided a value or it can be blank. What will happen then is the left-hand side of that expression on the generator side gets evaluated. So until send is hit, you have half of the expression evaluated and half not. And so you continue through step after step after step. The caller sends a value to a generator. The generator picks up where it leaves off and executes until yield and then hands back control to the caller. Now this keeps on happening until there are no more yields, in which case a generator will not actually return in the normal sense. Now there's a return keyword here, but as you see with that bottom step, in order to get the return value, you have to use the getReturn method on the generator. Now, this is all built in at the PHP runtime level. You don't have to implement these methods. This stuff just works. But if you're expecting a generator to actually return you a value the normal way when you call it, you'll be sorely disappointed. Now, we could go over and execute this, and actually let's go ahead and do that here. So this is what the actual call looks like. You'll notice that we're bouncing around in the program flow between the top of the file, which is where the generator is instantiated or defined, and further down where it's actually being executed. So if we do this, you'll see that the generator's at the top there. Now, one other piece, actually we'll hop to the next slide and then talk about yield from. So that was a basic coroutine. We were handing control back and forth from a caller to a generator. And the caller was responsible for telling the generator how much of that generator could be executed. In turn, the generator was responsible for saying, hey, I've reached a stopping point. Here, caller, here's control back so you can do something else useful. Now, that will come in handy when we start doing async stuff. One thing to note here, again, is that returns behave a little bit differently, but we can take advantage of that shortly. Now, you'll notice here that it said, well, we can delegate from one generator to another using the yield from keyword. I have another example for you. So in this case, we have something that yields 1, yields 2, yields from the generator up there. So this yield from keyword will actually effectively inline the execution up here to where all you have to do to get this yield 2 and 3 is to say, well, we're iterating over the outer generator. Generator is delegating to the inner generator. And let's see that in action. Now, one interesting thing here is that you can actually yield from an array, which actually cleans up a fair number of concurrent or in-order promise execution things when we're working on doing stuff async. So, like I said, I had to throw in a country-appropriate version of the yield sign because this definition of yield actually makes a lot more sense when we're talking about a coroutines execution. We're handing over back to the caller and saying, I'm done until you need me again. Rather than saying, well, here's a value, here's a value, here's a value. We're saying, I'm pausing my execution so that if the runtime has better things to do, then it can go out and do them. Now, let's take this into an application context. Your standard application is going to use maybe a load balancer in front of Nginx or Apache in either mod PHP running inline or PHP FPM running fast CGI workers talking over the fast CGI protocol. Now, the catch with that is that you end up having one copy of your application in memory for every concurrent request that you have to run, which may be fine because CPUs are relatively slow versus memory being cheap. Maybe that's fine, but there is still a trade-off there where one concurrent request means one process. And those processes are generally not going to max your CPU very easily. This is partially because the processes are sitting idle when you're doing any sort of network or file-based input and output where the CPU doesn't have anything amazing to do. but you're waiting on some HTTP request to come back down, or some file to be read or written, or some database query to come across. Also, for a 12-factor application purist, or for people saying that you should run one process per container in Docker, the Nginx plus FPM dynamic duo presents a problem for that, because you really want to have those sharing a fair amount of context unless you want to work around a few things. The flip side is that PHP is actually pretty good at waiting around and not using too many CPU resources while it's waiting for I/O. And all of your libraries and such are going to use the blocking method unless they're specifically built for doing something otherwise. So there's going to be a compatibility trade-off of what we're going to go into next. But again, there are some downsides to the traditional model of PHP execution. So let's see how we're doing on time here. Yeah, let's go ahead and demo this. So if we go over here. So I have a little, make sure that this is, OK. Mobile raffling system that we use for our local meetup. And any time that I do a presentation on anything heavily code related, I basically rewrite this little application because it's a quick rewrite and it allows me to illustrate various things. And today's presentation is no exception. So we're going to throw a raffle into the database here, standard MySQL deal. Yep, guess we're not. Actually, I'll bet I know what the problem is. That is 2028. What am I doing? Ah. OK, let's see if this works. Yeah, there we go. All right, so for those of you who don't mind sending an international text message, you can enter into the fictitious contest, and let's see if this works. And this. OK. So one thing that I did with this application is, by default, it's rather naive. It's sending, when I have to send a confirmation text message out, it's sending those serially. I could use guzzle async, but when I'm trying to demonstrate the benefits of async over blocking I/O, then that ends up making my further examples look bad. So I'll hit this button here. And so it completed relatively quickly. But if we look at the response times over here, I mean, it's a decent amount of response time here. It's not too bad because it's a trivial application, but we could actually do better. So event loops are all the rage. Node has them, and yes, you might be wondering, okay, the roads, at least the one on the right doesn't really look like a loop. Again, we call things weird in Texas. But to that point, event loops don't necessarily feel like you're programming in a loop either. The idea with an event loop is you program your application through, and any time that there is blocking input or output, you, via either promises or callbacks or generators, say, hey, application framework, I'm going to do some blocking input or output here, stuff that would normally block. Get back to me when that input completes, and I'll resume execution. So the event loop handler will sit there going through and saying, do I have I/O complete? Do I have I/O complete? Do I have, oh, I have I/O complete. Okay, what application or what piece of the application asked for that I/O? Okay, I'm going to hand control back to that piece of the application, let it execute whatever it needs to do, and then hand control back to the event loop as soon as there's some more I/O to do. So, given that, you don't want to block that event loop because not only are you blocking your own request, but you are also blocking anything else that is using that event loop. As such, you're going to see, and you have seen a number of Medium articles or whatever saying that we moved from JavaScript to Go because, well, when it came down to it, they were doing a fair amount of computation on inline in the loop. That computation wasn't the fastest thing in the world, and they were blocking every single other request that was using that loop. Not a good deal. And this is the sort of thing where if your application is actually compute heavy, you don't necessarily want to use this methodology. Now, callbacks and promises are the general way, or have been for a while, the way of interacting with event loops. The issue with callbacks and promises is while they at least somewhat work, they are kind of hard to wrap your mind around because your program flow is no longer linear. You can no longer read a function from the top to the bottom and say, this is executing in exactly this order. What you're going to end up with is a pyramid of callback after callback after callback, or promise after promise after promise, and you have to watch as your application goes like this off of your margins on your screen rather than going up and down. So generators actually resolves that because with generators, you can halt program flow partway through, yield to an external process, whether that is file I/O or maybe something else on the event loop if you want to checkpoint something that's computationally intensive, and then have the application call you back later without having to deal with callbacks or with promises, which, again, promises are just a kind of nice way of wrapping callbacks. Additionally, where with callbacks or with promises you have to have an error handler that is another function unto itself, with generator-based async, you can actually throw exceptions in either your I/O or catch exceptions in your main application logic, and it will actually work correctly. Now, here's the flow that you end up with. Here's the flow that you end up with when you're working with generators in a concurrent and an async setting. You start running, you have all your application functions as much as possible in generators if they're doing any sort of I/O where you're not just talking between CPU and another CPU. Anytime that you have blocking I/O, you yield a promise that is usually created by your async framework. So you yield a call to, for example, AMP, which is the concurrent PHP framework that we're going to see in a moment here, saying, hey, AMP, go get me this file, or go get me this database call, or go get me this file over HTTP. You yield there, or if you're calling some of your own code, you may need to yield from in order for it to execute all the way through. And then you rely on that async framework to call you back and send a value back into your generator when that promise is resolved with the result of that promise. Now, you keep on doing that. You keep going through your application logic, and any time there's I/O, you yield, and then you continue. And eventually, you get to the end of the function, and then you just return, because the async framework is going to handle that special getReturn call and put it in the right place. Now, if you've used Node.js relatively recently and seen their async await stuff, or if you had used HHVM a while back, then you've already seen this pattern. It's just that in the case of HHVM and in the case of JavaScript, you have functions declared as async rather than generators, and you have the await keyword used rather than yield. This is a very similar concept. Now, in order to make an event loop actually performant on PHP, yes, you can use the basic stream select and non-blocking I/O stuff, but what you really want to use is one of a variety of extensions, libevent, libev, or UV, which I believe at least at one point Node was using UV as their event loop. So you'll need to pull in an extension. The one that I've used personally is libuv, and yes, you can use this without an extension. It's just slower. The one I've used personally is libuv and the PHP UV extension on top of that. That used to be rather difficult to compile and install and get running. At this point, when I tested it very recently, it's a lot easier. It's mainly clone the PHP extension, build that after you've cloned down or added to your OS package manager libuv. So with all of that, we go from our standard PHP execution model where it's a client coming in and then our web server and then FPM or mod PHP to now our PHP process is actually serving HTTP requests, similar to how Node does it, for example. So that makes all the 12-factor people happy, and now if you need to have concurrency, then you do it the same way that the Node people do, which is you load balance a whole bunch of processes that talk HTTP. You can still use Nginx in front of that to, say, terminate SSL, or again, do round-robin load balancing, but you're now working at a bit higher level. So the positives of this method of working on things is now you're not taking whatever amount of time to bootstrap your entire application on every single request and then tear it down when the request is complete. You can now take a request, and then while that request is running, throw another request on there, and while that one is running, throw another one on there, and those requests can be concurrently multiplexed across the process that you're running, because chances are pretty good that while you're serving those requests, there is some bit of I/O that the server can be doing rather than just sitting there waiting for a database call to complete or an HTTP call to complete. Now, the downside of this side of things is now you're back down to having a single process, which means that it's very difficult to use more than a single core on, oh, right, we're in 2018. We have servers with 11 billion cores on them. So now you need to decide, okay, well, does this make sense for every application? And if it does, then now you need to, again, load balance at the HTTP layer across multiple of your processes, or have something at a lower level, for example, the AMP cluster library that will do that for you. Cluster library is kind of interesting, but it's, shall we say, rather experimental. So you get these benefits, and it's up to you to say, okay, well, I'm memory bound or I'm not memory bound. If you're memory bound, then having one copy of your application rather than 50 in RAM is actually a big deal. If you're bootstrap time constrained, then not having your bootstrap time, as long as your application does not have global state that you expect to be flushed out at every request, the lack of bootstrap time is a big advantage here as well. So with all of that said, let's start looking at some code here. Or actually, before we do that, let's do a quick demo of the AMP version of what we're talking about. And don't worry, that this is just going to be a little bit of Docker Compose stuff, so it's not terribly important that you see this. Okay, that looks like it's running. Now, if we look here, okay, it's 18 point something milliseconds. Okay, that's not all that great. Let's go ahead and refresh because that was probably hitting op cache. Okay, 2.13 milliseconds, that's better. So we went from, 8 millisecond bootstrap and that sort of thing to, okay, 8 milliseconds was virtually nothing. This is even closer to nothing. And I will go through here and a lot of that latency that you just saw there was the local network, because if we go back here, we're talking about 17. Okay. Most of that time right there is the actual database call, because I'm running MySQL in Docker, and that's not terribly happy about doing that. So using the same database there, and that. Okay, raffle complete. So we completed, and as I recall, that took a little bit less time than actually waiting for those text messages to send out, because we threw the promises for those text message requests onto the event loop. It was fire and forget. We didn't really care whether they returned, and we immediately returned the web request saying, we have the information that we need. We'll throw these effectively onto a queue that's managed internally by the process and trust that they actually get sent out. We don't care about what the response is. So let's look and see what the code looks like here. Make sure that this is the correct. All right, so let's start with the index file. So checking on time here. Okay, we got plenty. If you look through here, you'll notice that this is expecting to start up a web server on its own. It's not looking at a single request. It's actually binding to ports both IPv4 and v6. So you would run this script at the PHP command line to get your application up and running. Now, we're using AMP here to for a lot of these primitives, and saying, okay, AMP, go ahead and serve our static assets from the current directory, because I have this file in public. because remember, we don't have Nginx in front of this anymore to serve static calls. Now, let's jump over to the Bootstrap file here. Or actually, let's look at a smaller one here. SMS service, yeah, let's do that one. So in this case, what these functions are doing for Twilio or Nexmo is they are returning, instead of returning a response straight off, they are returning a promise that we can either decide to resolve right then or resolve later based on, or just let it sit on the event loop until it gets resolved because we're doing fire and forget. So what happens in these cases is as soon as the runtime has fired off at that request, you can get the response from this call right back, or the return from this call right back, and you can continue program execution elsewhere. Or in the case of you needing the result, you will still yield this promise and wait for the response to come back because you want the event loop to do other things while you're waiting for this response. And the yield keyword in a coroutine context will let you do that. So in this particular case, the routing layer of AMP, which has actually been redone relatively recently when they renamed their server from Eris, A-E-R-Y-S, however you pronounce that, to AMPHP HTTP server. They split out a number of components like routing and such, where now you can pull them in individually. You'll notice as we go through here, there's a yield here to parse form value because that isn't instantaneous. And as we go through here, you'll see a yield from here because that's a userland function that has multiple promises in it. And a yield from here, and so on and so forth. Now, in these cases, I'm calling into functions that I wrote or generators that I wrote. Let's see what we're looking at in terms of the code that we're actually sitting on top of. Okay, that is SMS. There we go. So one interesting piece of this is instead of a standard single, say, PDO connection, we're instantiating and requesting an entire pool of MySQL connections. The default for AMP, unless you set it differently, is 100 connections. And what that'll allow it to do is, since we're talking about this application, this single bit of code running across a whole bunch of multiplexed requests, you need more than one connection. Otherwise, you're going to end up blocked on database input. So you pass a pool in here, and when you actually need a single connection, you ask for it. So in this case, I'm saying, hey, peel off a single connection for me because I need something that is stateful, that I need the last insert ID to populate. And so that the system will do that with a single connection. And you can also use transactions within this to make sure that multiple statements end up on the same connection without actually having to pull a connection out of the pool. So you'll notice here that we have this, this advanced method. And any time that there is any sort of I/O, which fetching a result set does give you some input and output between the database and your application tier, you're going to, AMP is going to make it very explicit that that I/O is happening and saying, hey, you really want to let your whatever logic that you're doing stop for a minute, or a few milliseconds rather, get the data back, and then will hand control back to you when you have the data that you're looking for, rather than just sitting there paused with nothing else happening in the process while that response goes across. So as you go through here, this is more of the same, because this application is basically a bunch of database input and output, a couple of HTTP calls, which we cover on the SMS services side, and that's about it. Now, this does end up being a bit more verbose on the database side than PDO or a wrapper around PDO, but it does give you a little bit more control to make sure that the event loop is running for as much of the time as possible, so you're able to deal with a bit more scale in your applications. With that, I'll open it up for questions. That's all I have. I will post up the joined in link in just a moment. Slides are already up there. Code is already in GitHub, so you can look through this on your own time and just let me know with any questions.
So, who's got questions? Hands up there.
Thanks for the talk. So my question was, a couple of years ago we tried the React PHP.
Yep.
And we kind of merged that with the Lumen framework at the time.
Okay.
But we found the support wasn't great, and it was quite verbose to get a lot done. So we ended up switching to Node for a lot of our processing services.
Yep.
Do you think there's any advantage nowadays to using this approach over something like Node?
So, in all honesty, the community around Node, because it's an entire language and you can run it basically everywhere, is virtually always going to be better than the community around AMP. Now, on the other hand, the folks building on AMP are readily available, like in the Stack Overflow chat room and that sort of thing, and they're pretty responsive to issues. But because this is not the primary way of handling requests and responses in PHP, and it doesn't really have to be, because we don't have things that started out tied to an event loop and forcing you to deal with non-blocking I/O because you only have a single process to work with. This is always going to be a smaller community. That said, the folks who are there are pretty responsive. The flip side of that, though, is that in a lot of cases, while the code quality of the underlying PHP code to make this work is actually quite good and quite readable, they are pretty severely lacking in documentation on some pieces of the more complex stuff that you would get into on AMP. The base stuff like MySQL and the web server are generally pretty well documented, but once you get into some of your parallel processing stuff, where you can, for example, fork off child processes or even do multi-threading in the case of having pthreads installed, that stuff, you have example files, and that's about all the documentation you'll get. So if you're just going by community, then you're not going to beat Node in terms of people who already somewhat know how to do this stuff and have actually realized that with async and await, you can linearize your application flow so you can actually understand what you're doing on async rather than just having a whole bunch of promises and not knowing what hit you.
Okay, thanks.
Yep.
I think we've got time for a couple more if we've got them. Yeah.
Okay.
Hi there, thanks for the talk. Yes, it does seem like there's a real smattering of yields and not yields, and I guess the difference there is whether you're trying to be asynchronous or not.
Yes.
So if you miss one out, your code will run synchronously, and you might think you're doing fine, and then
So, actually, no. So anything that was listed in there that has a yield in front of it is actually yielding a promise So that the code, it's not that the code will run synchronously if you forget a yield, it's that the code will not run at all. Because your application is expecting a response, and what it's actually getting is a promise, and then, yeah, you can chain a then to that and break out of the generator-based workflow if you absolutely have to, but at that point, you need to switch back into that generator-based flow as soon as you possibly can. Otherwise, you end up with the event loop doing things that you maybe didn't expect it to. So anytime you actually need a result back in the flow of your code, you need that yield keyword. Otherwise, that task will complete asynchronously, and you can resolve that promise later, and that's no problem. But you're not going to, if you just pipe in, say, a database call and don't yield, then you'll get a promise that wraps the result of that database call rather than the result itself.
That sounds complicated.
It's the yield keyword is simpler than chaining than still kingdom.com, but it's an abstraction around promises. It's an abstraction around async. It doesn't take the entire problem away and say, oh, I'm just going to write synchronous code and it's going to act async. The underlying issue is still there.
Thank you. I may have got the wrong end of the stick here, but it strikes me that there's possibly you could use this as a testing solution if you're constructing maybe an API or a microservice that's due to talk to something else, that you could, in your generator, could you construct the answers you would expect so that your code can then interact with it on a give and take basis, or was that not?
That sounds like something that you could do. However, in order for me to follow you on what exactly you're thinking about, it's probably easier for you to say, oh, here's what I'm thinking it looks like in code, rather than me trying to guess.
Right.
But that does sound like it potentially could work.
Okay.
Got any more for any more? Fantastic. Well, thank you very much, Ian.
Yep.